Hey everyone, so here we are. Our lab today is on stoichiometry and mixture composition. So what we're going to do is we have a mixture right here, and this is a mixture of sodium carbonate and sodium bicarbonate. What we're going to do is to determine what the percent of each compound is in the mixture. So, what percent of this is sodium bicarbonate and what percent of it is sodium carbonate? How we're going to do this is by measuring the gas, how much gas is produced from the decomposition of the sodium bicarbonate. See, out of those two compounds, only the sodium bicarbonate will react. And when the sodium bicarbonate decomposes, it produces sodium carbonate, which is solid, and some water vapor and carbon dioxide gas. So the water vapor and the carbon dioxide gas are going to be released into the environment as we heat it up, which means that we can calculate the percent mass that is lost during the decomposition reaction. And we're going to use that to determine how much sodium bicarbonate was in the mixture to begin with. And so that'll give us the percentages of both. All right, so in a nutshell, that's what we're going to do. So let's begin. So first, we begin by weighing 2 grams of the sodium bicarbonate. We're going to do that on the analytical scale. We're trying to get 4 significant figures in this. So now that we have carefully measured the mass of the sodium bicarbonate, we're going to pour it into a clean and dry crucible. And make sure that we're getting all of it in here. And now we're going to heat up the sodium bicarbonate for about a minute. And we're going to put the lid on that, but we're going to leave it open, cracked open a little bit so that the water vapor can be released. And so during this minute, the sodium bicarbonate will decompose, and it's going to give us some sodium carbonate, which is an inert substance at that temperature. It will not react, but the water vapor will be released, and so the mass of the product will be less. And using the difference of mass and the balanced equation for the decomposition of sodium bicarbonate, we can calculate all of our stoichiometry ratios that we're going to need for part 2 of the experiment. So we're going to let this heat up for about a minute and measure the mass. So we placed the sodium bicarbonate, roughly the 2 grams that we measured precisely over there, with the analytical scales to get 4 significant figures. Now we put it in the crucible that was already pre-weighed, and we're going to heat it up for a couple minutes, about 2 minutes. And this is so that the sodium bicarbonate decomposes into sodium carbonate, water vapor, and carbon dioxide. So what this is going to allow us to do is to be able to determine out of the original 2 grams of sodium bicarbonate, how much sodium carbonate we can produce. So of course the mass of the product is going to be less than the mass of the reactants because the lid is partly open here, and so we're going to letting the gases escape. So we want to be able to calculate the percent of the mass that is conserved in this chemical reaction. So let's let it go for 2 minutes. All right, so after the heating of the sodium bicarbonate, and we've let it cool down, now we can take the mass. And this is actually the second heating, and we've done 2 heatings and found the mass after each one. And the reason that we wanted to do that is because we wanted to make sure that the sodium bicarbonate had completely decomposed the first time. So we heated it for 2 minutes, took the mass, heated it for a second 2 minutes, which you didn't see in the video, and this is now the second time we're taking the mass. And it is within 0.02 of a gram from our first measurement, so we're gonna call it good. And now we have the mass of the sodium carbonate, which is the product of the decomposition. That's what's left in here. The carbon dioxide and the water, of course, are gone into the atmosphere. So what's left for us to do now is to repeat this procedure, but with the mixture. And so we're going to do that. And we're going to take a sample of the mixture. So I got mixture C here. And we're going to start with 3 grams of the mixture. So again, I will, whoops. All right, and we're going to repeat the procedure. We're going to put this 3 grams of mixture, and we're going to put that in the crucible, and we're going to heat it up for a couple minutes again. So here we are with the mixture in the crucible. Now we're going to light the burner. Lid is partly open, and we're going to heat the mixture again for 2 minutes, and we're going to take the mass, heat it up again for another 2 minutes, and take the mass again. We have now let the crucible cool down after heating the mixture for 5 minutes. So here's the mass of the crucible and all of the sodium carbonate resulting from the decomposition of the sodium bicarbonate that was in the mixture. So now with this number, we are ready to do our calculations, and I will help you with that. All right, everybody. So in the lab today, what we have to do is we're given a mixture, and this mixture we place in the mixture in the crucible is sodium carbonate and sodium bicarbonate. So our job today is to figure out what's the percent of sodium carbonate in the mixture and the percent of sodium bicarbonate in the mixture. So we want to know what's in there. We come from understanding that the sodium carbonate will not react. And so therefore, the only reaction that's going to take place when we heat this up is the sodium bicarbonate. And the sodium bicarbonate is going to become sodium carbonate, and then it's going to produce H2O and CO2, which are both gases. So what's going to happen is we're going to balance this equation first. So we have 2 sodiums over here. We'll put a 2 in front of the sodium bicarbonate, and that takes care of that. All right, so we know this is not going to react. So what we're going to do is we're going to heat up the mixture, and these 2 gases are just going to go away, which means that the mass of the reactants should be equal to the mass of the product, and so we're going to subtract these 2 product, and so we expect, of course, the mass of the product to be less, because this is the only thing that's going to be left out of the 3. So we could do it as a stoichiometry ratio, and we could just figure out so the molar mass of sodium bicarbonate at 84 grams per mole, right? And we would times that by 2, so we have 168 grams. And according to the Stoich here, we see that, so 2 times 23, 12, and so that's 106 grams per mole. So 168 should give us 106. So we could do the stoichiometry like this, but we don't know that our reaction is going to give us 100% yield. So what we did in the lab is we started with part 1, where all we did was the decomposition of sodium bicarbonate into sodium carbonate. So the point of that was just to verify, to get an idea of what kind of yield we were getting. And so when we did this, when I started with 2.1132 grams, I got 1.33 grams, right? So basically what that does is it shows us that 2.1132 minus 1.33, so it tells us that 0.7832 grams is the amount of gases that we produced. So what we could do then is to say, okay, well, what's the percentage of gas produced to the amount that we started with, right? So 0.7832, if we divide that by the amount that we started with, then we have 37%, 37.06%. So 37% of the mass of sodium bicarbonate is lost. Well, now we have the information that we need to go to part 2, because we have an actual yield. If you do the stoichiometry, you're going to get actually very, very close to a 37.06. So our yield was, our percent yield was actually pretty good. But so if we repeat this calculation, but we're using the mixture, which is what we did in part 2, right? We started with the mixture instead of this, but it's actually kind of the same thing, since in the mixture the sodium carbonate doesn't react. So the only thing that's reacting in there is this. We started in the mixture, so this was part 1. Now in part 2, it's exactly the same reaction. What we started with was 3.2602 grams of the mixture. And then we heated that up, and after the fact, it weighed 30.25 grams. So don't forget, this mixture here was in the crucible, which we had weighed at the very beginning at 38.10 grams. So the initial mixture, 28.10 plus 3.2602 is 31.36 grams. So 31.36 turns into 30.25. So if we do that, we can find out the mass of gas that was produced, right? Which is the difference between the two. So (1.1102 grams. Now remember, we're going to assume that since we did the chemical reaction exactly the same way, we're going to assume that we're getting the same yield. So what that tells us is that this 1.1102 grams is 37.06% of the sodium bicarbonate that we started with. So we're going to take that amount, 1.1102, remember this is 37% of the sodium bicarbonate that we started with. So if we divide that by 37.06%, that's going to give us the amount of sodium bicarbonate that we started with, 2.999. We're at 3 significant figures. So given that we lost 1.11 grams in gases, that tells us that we started with essentially 3 grams, right, of sodium bicarbonate. Now remember that the task in this activity was to figure out what's the percent of each compound in the mixture. Well, now we just found out that the sodium bicarbonate, this part of the mixture here, is 2.99 grams. Remember, so our mixture was 3.2602 grams. And we're finding that this mixture, which was sodium carbonate, and sodium bicarbonate, now we just calculated that this portion of the mixture was 2.999 grams. And so we can figure out the proportion, the amount of sodium carbonate, so 3.2602, and that's 0.2613. So that's how much of each one we had in the original mixture. We can find it as a percent, 2.999 divided by 3.2602. And that gives us 91.99%. So we can say that the original mixture was 92% sodium bicarbonate and 8% sodium carbonate. I hope this helps you with the lab. Good luck.